Geometric sequences. Geometric sequences. I think I'm upside down. Yeah, we're starting. Oops, wrong color. Shh, 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 shh. All right, we've been in this unit for a while now, yeah? So, $11.28. Geometric sequences. Well, that's blurring, which means this got blurred. That better? All right. What other sequences have we done? We did do arithmetic. Arithmetic, we didn't actually solve them, right? Did we solve them?
No.
We just graphed them, right?
Yeah.
Where's my notebook? I moved it. Okay. Let's do this. Oops. How do I find a geometric sequence? And graph it. Yeah. Sir. Is today worse than yesterday? No. Did you go to bed earlier? Should probably switch the schedule so I know time to bell rings. All right, what is a geometric sequence? Let's talk about it. A geometric sequence is a numerical, what's numerical mean? A number pattern in which each term after the first number is found by multiplying by its common ratio. So it's a numerical pattern in which each term after the first number is found by multiplying by its common ratio. All right, I'm going to underline the word common ratio. Because do you know what a common ratio is? Nope, me neither. Well, I do, but I'm just going to underline it like I don't know. And then the key word in here is that we find it by multiplying. Do you see that word multiplying? That's a key word. So we need to know that that is a key word. Since we just underlined the word common ratio, then let's go ahead and what? Let's define it. Hey, sir. Yesterday you were going to...
My name is Siri.
Thanks, Siri. Mr. Romeo.
Huh?
At lunch yesterday, where were you? Uh-huh. Common ratio. Common ratio is denoted by the letter R. Denoted means we represent common ratio with the letter R. Okay? So common ratio, it is the constant. And remember, constant is a what? A number without the variable, just a number. You need to know the difference between constant, coefficient, terms. It's on your test. Make a flashcard. It's the constant, which is a number that is used to continue the pattern of terms in a geometric sequence. All right, we okay? All right, just so you know, the common ratio is a number being multiplied. In other words, it's just a number being multiplied. Easy words, right? The constant number that is used to continue the pattern of terms in a geometric sequence. So let's write the geometric sequence so you know what it looks like. We did arithmetic sequences and we graphed them. We haven't actually computed them, but we did graph them. And by graphing them, we plugged in numbers, right? And that was on our quiz, and then some of us didn't do it right, or we graphed it wrong, remember? So we have a sub n. The last one was also a sub n. This one's a little different. It's a sub n equals a sub 1 times r to the n minus 1. Arithmetic made a what? Do you remember? What did it form when you graphed it? Form something. What kind of graph was it? It was a line. What do you think this is going to form? Why would it be a line? Where's your variable? R is not a variable. R is a what? It's a number. A sub 1 is a number. So where's your variable? In the exponent. And if my variable is in the exponent, then I have a what kind of graph?
A slope. No. It's a, I don't know the word, but it goes like that.
Exponential. Hence the word exponent. I know. Yeah, see what I did there? Here we go. Remember, this is the nth term. It's the nth term. Nth. This right here is the first term. The R is the common ratio. Yeah, we just wrote that up here. And since it's an exponent, we have what kind of graph? Exponential graph. From here. Hit escape, please. And then make it big again. Yeah. And then make it big again, like click the, right there. There you go, thank you. Escape. Oh, my stapler. I thought you meant like shoe, like my real shoe file. No, like yours. I'll have to get it. Are we okay? Questions? Let's go to the next part. The first part is examples. This example says determine if the sequence is geometric, then explain why or why not. So determine if the sequence is geometric, then explain why or why not. You're starting with 5, 10, 20, 40, and 80. All right, ready? So, pay attention. Just watch. I'm not going to do anything crazy, but I want you to watch. So, because 5, 10, 20, 40, and 80. Remember, sequences start with A sub 1. Then it's A sub 2. Then it's A sub 3. A sub 4, and A sub 5, right? Because that's the first term, second term, third term, fourth term, fifth term. Right? Make sense? Okay. We did this before when we plugged in 1 and we plugged in 2. Remember we had the arithmetic ones? Now, all you're going to do, now watch. This is easy. You're going to take A sub 2 over A sub 1. And when I really say over, I don't mean over, I really mean what? Divide. So what is A sub 2? 10. 2 is 10. Yeah? And what's A sub 1? 5. And what's 10 divided by 5? 2. Okay, so I hope, because it says determine if the sequence is geometric. For it to be geometric, every time I divide, I should get what answer? I should get 2. Okay? So I'm going to do the next one. The next one, I did 2 and 1. Now I need to do 3 and 2. Okay? You just go back 1. So a sub 3 is how much?
20.
Good. And a sub 2 is?
10.
And what's 20 divided by 10? 2. Oh, wait. So far it's 2. I'm hoping that the rest of them also give me 2. You understand? But I have to prove all of them. So what's the next group I'm going to prove?
40 and 20.
A sub 4 over a sub 3. What's a sub 4? 40 divided by 20. What's 40 divided by 20? It's 2. What's last? A sub 5 divided by a sub 4, which is equal to 80 over, which is, we're good? So then you're just going to say that R equals 2, and yes, it's what? It's a geometric sequence. That was easy, right? We good? Okay, let's do another one. Okay, second example, here we go. You're going to try to prove that -2, 6, -18, 54, and -162 is a geometric sequence, yes or no? Okay, if you need a calculator, you can use it. -2, 6, -18, 54, and -162. Remember, you're going to show the work just like I did. So I wrote a sub 1, a sub 2, remember that? So you're going to follow the same pattern. I can't talk. Check with someone if you have an answer. Ready? Who has an answer? Okay, about half of you. All right, let's see. We do negative 2 is a sub 1. This is a sub 2. This is a sub 3, a sub 4, and a sub 5, correct? Okay, you should have written a sub 2 divided by a sub 1 equals 6 divided by negative 2, which is what? Negative 3. Then you should have written a sub 3 over a sub 2, which is negative 18 divided by 6, which is how much? Negative 3. So far, so good. A sub 4 divided by a sub 3 is 54 divided by negative 18, which is negative 3. And a sub 5 divided by a sub 4, which is negative 162 divided by 54, which is what? Bless you. Negative 3. So you're going to tell me that R equals negative 3. Yes. Geometric sequence. Good? Question? All right. We are going to do an example where it's different. What time's the barn? I have 3. We're not even going to find the first 5 terms. I'm just going to start you off with it, okay? We're going to do a sub n equals 2 times 3 to the n minus 1. Okay? All right, you're going to make a chart where you have n, you have your function or your sequence, a sub n, and then n comma a sub n. Yeah? Okay. When it says find the first 5 terms, that means you're going to plug in 1, 2, 3, 4, 5. Make sense? Okay. Now, watch what I do. I'm going to do a sub n, so a sub 1 equals 2 times 3 to the 1 minus 1. Right? What's 1 minus 1? It's 0. Now remember, something to the 0 power is what? It's 1. But only this piece is 1. This really says 2 times 1, which is how much? Which is 2. So this is 1 comma 2. Does that make sense? Okay. I'm going to do a sub 2 for you really quick. So we're going to do 2 times 3 to the 2 minus 1. Right? And then that is 2 times 3 to the, what's 2 minus 1? First power. You do 3 to the first. How much is 3 to the first? 3 times 2
6.
is 6. So 2 comma 6. Make sense? A little bit? Okay. You can try 3. I'm going to pass out your homework and I'm going to tell you what I want you to do. So try 3. Should have 18?
Yeah.
Okay. I'm going to tell you what I want you to do. Ready? This is just to get you started. What I want you to do right now is this. On the back of your homework, flip it over. On the back of your homework, I want you to do this problem. A sub n equals 2 times 2 to the n minus 1. You're going to do the first 5 terms, and then I want you to sketch a graph. Understood? So you're going to do a sub n equals 2 times 2 to the n minus 1. You're going to do the first 5 terms, so like we started right here. And the last thing you're going to do is sketch a graph for me. Okay? Remember, it should be what kind of function? Exponential. All right? I will see you tomorrow.